So welcome to our performance testing and engineering live training. So in the last demo session, Sourav gave some, introduction to the his performance engineering training with open source tools. So today's demo session would be, purely technical demo session. So I have Sourav with 15 plus years of experience in performance engineering. Hope everyone will get benefited by his rich experience in performance engineering. By the way, we are starting, new batch for performance testing. Let me show you the course contents. So these are the course contents for freshers and beginners. We are starting a new batch for performance testing on 25th July, and we do have a YouTube channel. So please like, share, and subscribe to our channel. So this is our YouTube channel. All right. So and as I said, so we are starting a new batch for this, covering these performance testing concepts from 25th July. The same day, we are planning to start performance engineering session by Saurav Kumar. So now I am handing over to Saurav. Saurav, please go ahead.
Yeah, sure. Thank you, Kishore. So let me start sharing my screen. So Kishore, if you can unshare.
Yeah. I stopped my screen share. I'm making you host.
Okay, great. Thank you.
Done. It's done.
I hope you are able to see my screen now, everyone.
Yes.
Okay, great. So yeah, good morning. I believe everyone who have joined for today's session are all from India. So good morning, everyone. So let's get started. Last week when we had that first session, it was a kind of introductory for everyone, what kind of topic that we are going to cover in the performance engineering. And we have went through this entire course that what we are going to cover and what kind of tool that we are going to use. So today's session, especially, I am focusing on picking up one particular topic and at least try to give that overview that how we are going to conduct our technical session specifically. Okay, so today's session, just an example, I picked it up for garbage collection in Java, right? This is very popular topic, and it is definitely one of that hot topic when you are going for an interview, for sure, right? People in the performance engineering, when they are going for this particular, when they are going for a job opening, right, job interview, most of the time I have seen that people are expected to have knowledge in a garbage collection. And specifically, since Java is a very popular language and most of the enterprise software written in Java, garbage collection becomes an automatic choice for having questions from this particular area. Okay, so before that, I would before going into that garbage collection in Java, right, I would like to discuss about how programs in Java runs, right? When you are planning to do an execution of Java application, how and what are the steps involved to run a specific Java program. Also, I would like to make this session more interactive so that people would come forward and ask questions, right, rather than just listening. So I believe we have a sizable audience here. Anyone knows that what are the steps involved when you are executing a Java program? Anyone of you? By the way, you know that Java is so-called a platform independent language, right? So it does it in two different. Okay, guys, please feel free to share your thoughts. Right, even if you are unsure, don't hesitate to share your thought with us. Right, it would bring a clarity in you, and definitely it is worth sharing your ideas with everyone. Okay, so please don't hesitate. That's what my point is. So it's a two-step process when you are trying to execute a Java program, right? The first step is a compilation, and the second step is a interpretations through JVM. We have a standard tool for compilation. Compilation, we are doing it through Javac. So Javac is a standard compiler given by the Sun microsystem. Okay, now taken over by Oracle. So what it does, the compilation by Javac. Javac is a tool which does the syntax checking. Okay, so it scans through the code, it checks syntactically it is written correctly or not, and then it encodes the Java source code into something called byte code, right? Which is a machine independent encoding. Java bytecode, just for your information, is that instruction set of the Java virtual machine. In nutshell, you can say. So each byte code is nothing but is a composed of one byte that represents the opcode, right? And along with 0 or more bytes for operand. So let's take an example what the opcode and the operand means. I believe you have some sort of understanding on programming languages, right? If you wanted to add two numbers, let's say A equal to B plus C, at a programming language level, you just write it, right? A equal to B plus C. But what operations we are trying to do it here? We are trying to do operations like addition. We are trying to do operation like storing, right? Storing in the sense when we add B plus C, we have to store it back to A. So we are doing quite a few operations in the background like fetching the value from B and C, then add it up and then store it back to location A, right? Each and every operations, if you closely look at it, contains two things. One is the operation itself, and the operand means on which variable the operation is being performed. Like A equal to B plus C, the addition operation is being performed on two operand, that is B and C. Okay. Once the addition is done, we are trying to store the summation of B and C to that location A. Now, the operation here is store, right? Operand here is A. So each and every instruction, each and every statement at a programming language can be further divided into operations specifically and or instruction. So I'm trying to give you that understanding just because it will help you to understand what the Java bytecode consists of. Okay, so I'm just repeating. Java bytecode is the instruction set of the Java virtual machine. Each bytecode is composed of one byte that represents the opcode along with the 0 or more bytes for operands. Okay. You probably understand this. The bytecode, if you have come across a Java programming language, you probably understand that when you compile a Java file with the help of Javac compiler, it gets into class file. So this byte code is basically for each and every class we have a class file. This is the byte code we are talking about. Okay. Nevertheless, this class file generated by the Javascript compiler are independent of the machine or the OS, which allows them to be run on any system. So, yes.
Sorry to interrupt you. We are still seeing the slide only. Are you showing some other screen?
No. You're able to see the slides, right?
Yeah, we are seeing the slide deck only.
Okay. I was just referring to these slides only, Kishore. Okay. So, as I mentioned, that this is the first step of running a Java program, right? We heard of that Java is a platform independent language, right? How Java achieves platform independence is that you can compile the Java, any Java program, independent of the machine or OS. Okay. It is the JVM, which is basically meant for interpreting this .class file or the bytecode, is basically a platform dependent piece of code. Platform dependent in the sense, it is depend on, you would probably find a different flavor of JVM based on the OS operating system. You have a different flavor for Linux, you have a different flavor for Windows, and you have a different flavor for Solaris as well. So point here is that compilation by Javac is the first step for executing your program, Java program. And the next step is an interpretation. Interpretation is nothing but going through each and every instruction and execute it during the runtime itself. Okay. JVM, in the acronym of JVM is Java Virtual Machine, provides a runtime environment for your Java program to run. Okay. It takes your main class files, that is .class file, and start interpreting line by line, and then transform into machine understandable code, okay, which will ultimately get executed on that machine. As I mentioned previously, I'm repeating, JVM is platform dependent. That means you would have a different flavor of JVM based on the OS operating system you choose, right? If you go to that Oracle site, you'd probably find, okay, let me show you that quickly. Are you able to see my Chrome?
Oh, we are still seeing slide deck only.
Okay, I think let me unshare and share it again, huh? I hope you'll be able to see my screen now.
Yes.
Hey, Kishore, you are able to see my Chrome?
Yes, yeah.
Okay. So I'm on Oracle page, right? We are talking about JDK. JDK is nothing but Java Development Kit, which provides you a development environment or development kit for creating Java programs. it does include, it also provides you the JVM as well. Okay. As you are seeing that on the left side, that we have JDK, which are meant for Linux. Alongside it also, you will be able to find one more thing is ARM32, ARM64, x86, right? So x64 RPM package, these are different instruction set architecture or ISA. Okay. So as I mentioned that JVM is platform dependent. It is dependent on the operating system. So you would find JDK for Mac OS as well. If you come down further, you will get it for Windows. You will get it for Solaris. Okay. Alongside, you would also find it different flavors of JDK for different instruction set architecture. Now, what exactly is instruction set architecture like x86, ARM64 or 32? I can give you a brief about it. Instruction set architecture is probably, you can, in a simplest way, you can treat it as this is that very low level language meant by your system or your CPU. So CPU understand this instruction set architecture and it only execute those instructions. Each and every platform is having a different set of instructions. ARM is a very popular, x86 is also equally popular architecture available in the market at this moment. Example of x86 architecture, you probably heard of Intel's Xeon. Okay. Intel's Xeon is based on x86 architecture. Okay. 64 and 32 bits, these are different different bit, okay, of instructions, means how you wanted to what are that address bus you wanted to use to have this particular piece of code running on your system. Okay. And nowadays we are using mostly 64-bit, but we are still used older 32-bit as well. I'm repeating again, JVM is a platform dependent piece of code or piece of utility which provides a Java runtime environment also. Okay, it is platform dependent. It is based on the OS operating system that you have been using, also the architecture that you have been using for your system. Intel is a very popular CPU which is based on x86. ARM is another popular CPU which is based on ARM ISA or instruction set architecture. AMD is also using x86 architecture. Okay, so we have a different flavor, 32-bit versus 64-bit. Now we are mostly using 64-bit. Okay, so if you wanted to run a JDK on your system, what you have to do is that since this is a Windows machine, we have to go for Windows x86. x86, it's a 32-bit JDK. If your system is 32-bit, please go ahead and download this one. If your system is 64-bit, then probably you have to go and download this one. Okay, you are able to see these are two different packages. Sizes are different, 154 MB versus 166 MB. So choose the correct package before start using it. Okay, so this is how we choose the JVM or JDK for execution. Now let me go back to the presentation again. I was talking about interpreting the dot class file, right? Interpreting it line by line. And this is one of the reason Java is a bit slower than other traditional C or C++ language. C or C++ language is directly compiled into machine understandable code. And that is why they are a bit faster than Java. Okay. Java understands the problem because Java wants to achieve the platform independence. That's why they have divided that execution process into two halves. One is compilation, another one is an interpretation. Okay. Since Java interprets based on line by line interpretation, it becomes slower. Now, there is an advanced concept called just-in-time compilation, through which it's trying to fill the gap between a programming language like C and C++ and Java, right? Through Jit compilation, Java is trying to fill the gap to make that execution much faster than that earlier version of Java, right? So Jit compilation is an important step in the Java runtime environment. It's a part of JVM through which we achieve faster execution of Java application. Okay. So Jit compilation is one phase, I would say. Okay. There are various other phases like class loader. Whenever you are executing a program, the first and foremost part is that you have to upload or you have to load the main class and the relevant classes into the main memory, right? The main class is loaded into the main memory by passing its dot class file. So when you are running, so as I told you, right, it's a two-step process. You first compile the Java program through Javac, and then in the next step, you feed this dot class file into a Java JVM. For number one step would be class loading, okay, through invoking the main method, and all the other classes referenced by the main method are also getting loaded into the main memory, okay. Primarily, we are using Bootstrap class loader, which is a default class loader in Java Virtual Machine. This is also known as a primordial class loader. Okay. There is another class loader, custom class loader, which you can also use it. But as I told you, the Bootstrap class loader or the primordial class loader is the default one which you use when you don't mention anything in specific. As a part of JVM, we also have something called bytecode verifier. Bytecode verifier does what? Bytecode verifier verifies certain thing like whether the variables are initialized before they are used, or rule for accessing private data and methods are not violated. Okay, so you probably heard of private access modifier. If you are aware of access modifier, through access modifier, you can control the visibility of certain variables, classes in Java, and you can restrict the usage of those from unnecessary access. Okay, so it is the bytecode verifier which does all this stuff, and if it sees there is a violation, it will not allow you to run your Java program. Okay, so two important sub-process by the JVM is number one is a class loading, and second thing is that bytecode verifier, and the third thing is that the just-in-time compilation, right? Ultimately, this just-in-time compiler does convert the loaded bytecode into machine understandable code. Okay, so again, let's focus on this page one more time. two-step process for your execution of your Java program: compilation and interpretation. Compilation is done by a traditional JavaC compiler, and JavaC compiler was created by Sun Microsystem earlier. The second one is JVM. JVM provides, or Java Virtual Machine provides, a runtime environment to your Java program, which does class loading, bytecode verification, and as a part of it is a just-in-time compilation, which converts your bytecode into machine understandable code. Okay, I would like to take a pause here, and if you have any question, please feel free to ask. Any questions on this? Kishore?
One question.
Yeah.
One question.
Yeah, please go ahead.
So, what is the difference between a compilation and a just-in-time compilation? Is both one and the same?
No. The compilation done by the JavaC is a step which is required to generate the .class file, right? Just-in-time compilation is a part of execution. When the Java program is in execution, the just-in-time compilation kicks in to make the Java process or the Java application run faster. Okay, so fundamentally these are two different things. As I mentioned, JavaC compilation is a pre-process or pre-steps required before you start executing your Java program. Okay, so fundamentally these are two different things. One runs before you start executing your Java program, and it helps you to generate .class file or bytecode. And then during the JVM, when you are running your Java application through JVM, the .class file or the bytecode takes an the JVM takes it as an input, runs it, and then the just-in-time compilation kicks in. So one is at that static side, static compilation. Another one is a kind of when the program is already in execution, just-in-time compilation kicks in. These are two different processes. They are meant to provide two different purposes. Okay, I will walk you through what exactly just-in-time compilation does.
Thank you.
Okay, any more question here? Okay, I'll go to the next slide, and may I know your name, please, if you don't mind.
My name is Ratnakar.
So Ratnakar, we'll come to this just-in-time compilation in few minutes. Okay, let me walk you through the Java virtual machine first, and then I will come. I have a full slide dedicated for just-in-time compilation to give you the overview.
Okay, thank you.
So Java virtual machine, as I mentioned, that it is a virtual machine. You probably heard of virtual machine like through ESXi, like VMware virtual machine you heard of, right? It provides virtual machine through VMware or ESXi, or through hypervisor provides you an environment that is an machine in isolation on the physical box, right? So instead of having one physical machine, you could deploy n number of virtual machine, and these virtual machine can run independently, okay, up to each other, right? So similarly, Java virtual machine also provides an execution environment for your Java program, right? It enables your computer to run Java program as well as programs written in other languages. So please pay attention. JVM is not only meant for Java program to run, right? There are various other programs like Closure, Kotlin, Jython. Jython is nothing but a Java version of Python, which are JVM-based languages. Okay, they were built in keeping in mind that they will run in two-step process. As I mentioned earlier, the last step or the second step is through JVM, so that that code would be interpreted line by line. So Clojure, Kotlin, and Jython, these are the language, is a JVM-based language. These are similar. These languages are taking a similar approach like Java to get that runtime environment for running those programs. So JVM provides you an environment to run your Java program as well as programs written in other language that are compiled to Java bytecode. Okay, so Clojure, Kotlin, Jython, they are, before they are getting executed, they are also getting transformed into the source code, getting transformed into the bytecode. Okay, so JVM provides environment not only to Java but each and every language which is JVM based. Just for your information, it's good to know that the JVM reference implementation is developed by the OpenJDK project, right? It's an open source project. You probably heard of Hotspot, you probably heard of JRocket, you probably heard of J9. These are the different flavors of JVMs we have. But ultimately, what we are going to discuss, and focus mainly on the hotspot. So this JVM reference implementation is mainly developed by the OpenJDK project as an open source code and include Jit compiler called hotspot. Okay. I already mentioned JVM consists of the Java interpreter as well as the Jit compiler. This and also a few sub processes called bytecode checker as well as class loader are also part of the JVM. Why Jit compilation? As I mentioned, that I will go through it in detail, but Jit compilation is meant to provide you a faster execution environment for your Java, right? Interpretation is having a slowness in its nature, right? It interprets line by line, unlikely to compilation. So it may slow down your entire execution of the Java program, but with the advancement of Jit compilation, slowly we are closing the gap between these two approaches. Okay. Already I mentioned that Jit compiler translates Java bytecode into native machine language while executing the program. Then the translated parts, once it gets translated into machine understandable language, the translated part of the program can then be executed much more quickly than they could be interpreted, right? This technique gets applied to those part of the program which is frequently executed, right? There is quite a few concepts that we would learn from today's session, how Jit compilation helps in improving the execution time, okay? Jit compiler is significantly speed up the overall execution time for sure, right? Few example I would like to give, like hotspot I have already discussed, and our main focus would be on the hotspot JVM, but there are quite a few good JVMs are available in the market. Right now, we don't have JRocket, by the way. JRocket was a BES system product, but since Oracle overtakes or acquires BES system, the JRocket gets merged into the hotspot. Okay, so I'm just trying to give the history that how hotspot is has become #1 JVM for enterprise software, right? Enterprise Java software. First of all, Oracle acquires BES system. BES system had a JRocket JVM. Okay, JRocket JVM was one of the most popular JVM in the market in 2000, early or mid 2000s, I would say, till Oracle acquires BES system. BES system was acquired by Oracle in 2008, I believe, if I'm not wrong.
Yeah,
So till that, yeah, sorry.
Company which developed the WebLogic application.
Yeah, exactly. So JRocket, since it acquired, Oracle acquires the JRocket system by acquiring the BES system, it was trying to merge both hotspot. Okay, and by the way, the biggest acquisition happened in 2010, I believe, when Oracle takes over the Sun Microsystem, right? So the hotspot JVM becomes a part of Oracle. Now the both JRocket and hotspot became a part of Oracle. Oracle trying to merge these two and trying to phase out the JRocket, okay, in the process. So right now, if you are using JDK 8 or the newer version of JDKs like JDK 11, okay, you would probably see only one JVM, that is hotspot. Few best practices Oracle take it from JRocket, like you probably heard of Metaspace. Earlier you used to have something called permanent generation or PermGen. There are definitely JRocket had this Metaspace concept, and Oracle borrowed the Metaspace concept from JRocket and merged it into hotspot. Okay, so right now the hotspot, as I mentioned, is a big combination of best practices for both from hotspot, earlier version of hotspot, and JRocket. Okay, we'll go through all this Metaspace later when we start discussing about that anatomy of JVM in detail. But just for your information, we have something called hotspot at this moment. We earlier had JRocket. Right now, there is another popular runtime environment we have called OpenJ9, kind of extension from J9 from IBM. Okay, we have other JVM providers like Azure, which is having some unique behavior the way JVM runs. Okay, if you are interested, I can discuss during the course itself. But again, our focus would remain on the hotspot, since it is the most popular JVM being used by the industry at this moment. Okay. I'll complete this slide and then I would take a pause and take up your question. Okay. Okay. So going forward, I am not going to discuss anything about the JavaScript compilation. JavaScript compilation. Hey, if you don't mind, can you just give me a minute? Kishore, just give me a minute, everyone.
Sure, sure.
Hey, sorry guys, I got a call. As I mentioned that, hey, Kishore, you are able to hear me, right?
Yes, yes. Yeah, please go ahead.
So as I mentioned that JavaScript compilation, we are not going to discuss anything, at least for today's session anymore. JavaScript compilation, just for a reference once again, it provides you it actually transfer your source code, that is .java file, into your .class file. So it transforms your source code into byte code. Okay, and that's the static compilation that we are talking about. So henceforth, whatever we are going to talking about compilation is a runtime compilation. The Jit compilation specifically we are going to talk about, right? And the other compilation available as a part of JVM, that is also going to be covered. Okay, so why I'm telling this, let's stop discussing about Java-C. I just wanted to make sure that we don't get confused with Java-C compilation versus compilation or compilation provided by the JVM, right? Henceforth, we are going to talk about compilation provided by the Java runtime environment. Okay, so Java, as I told you, that once it gets the bytecode and it gets fed into JVM, it starts interpreting. Okay, it does also JIT compilation. So JIT compilation, let me reiterate, just-in-time compilation. It's a runtime provided compilation to make sure your Java program run faster. Okay, how it achieves the fastness in running that Java program. Let's take an example. If you are running a program in a loop, it's a piece of code you are executing in a loop. Or let's say you have written a particular method in Java and you are calling this method very frequently. Okay. Now think about two scenarios. Number one scenario is you are only doing interpretation. You are not involving just-in-time compilation. What it does, once the bytecode fed into that JVM start interpreting line by line. Okay, so it picks up one line, interpret it, and then transform that particular line into a machine understandable code before going into the second line. Okay, so interpretation is always line by line. It slows down your Java execution performance, right? As you understood correctly. So for a situation or for a scenario like you have a method which is being called multiple times from your program, okay? Every time you call the particular method, you have to interpret it, you have to execute, transform into machine understandable code, execute it, and then again, when the next time that same method gets called, you have to do the same process again and again. Doing the same process, doing the interpretation for the same method again and again eventually slows down your performance. Okay. What Java came up with, Java says that if you are executing a same piece of code multiple times, it automatically becomes a hot method. Okay. And it provides you an implementation called Java just-in-time compilation, so that it intelligently detects if the method or a piece of code become hotter. That means it gets executed multiple times. It directly transforms the code into machine understandable code. So next time you execute the same method or same piece of code, you don't have to interpret it during the runtime. And that is how it achieved the fastness. It achieved fastest response during the execution itself. I'm repeating again. Okay, there are two scenarios, which is number one is a default one. You are doing just an interpretation. So every time you are going through the same method, it has to interpret it. It has to transform into machine level code or machine understandable code, and then it gets executed. Okay, so every time you are executing the same piece of code or same piece of method, you are doing the same exercise again and again. Okay, in the second scenario, Java came up with a situation or a feature called just-in-time compilation, and it says if you are executing the same method or same piece of code, let's say n number of times before it gets an hot method or hot piece of code, let's not do the interpretation again. Rather, JVM will create the machine understandable code for this piece of method directly, and then next time it being called, it will directly convert into machine understandable code rather than going through the Java interpretation. Okay, that is how just-in-time compilation achieve faster execution time than the traditional interpretation mode. Ratnakar, now are you getting the point what just-in-time compilation is and how it is different from traditional or JavaScript compilation?
Yes, now I understand.
Good. So there are various options, means you can try and test it whenever you have a time. You can execute your Java by mentioning that -xint that you want to execute your Java program only in interpreted mode. That means just-in-time compilation will not be kicked in anytime. Okay. So are you able to see that option -xint is that you are giving that JVM or saying the JVM that only interpretation should be in action and do not kick in any just-in-time compilation. Okay. The next option is -xcomp, which is how we are telling Java runtime environment to use only compilation. Okay. And last is -x mixed, which is the default one. Default one means if you are doing a Java Finance version, you would get a mixed mode always. Okay, so JVM runs in a mixed mode always. So it's a combination of interpretation as well as just-in-time compilation to execute your program. Okay. Why mixed mode? There is definitely a reason for mixed mode. We'll discuss when we are going through this particular topic in our training session. Okay. I would like to mention that JIT comes with the two flavors specifically. The C1 compiler, or which is also known as the client compiler. Another compiler, we have C2 compiler, which is a server compiler. Both the compiler has its own pros and cons. C1, like client compiler, is meant for those applications which needs to be started very fast. Okay, like you probably heard of gaming software, right? If the gaming software is means the UI rendering is slower, what would happen? You would see, you will not get a seamless experience, right? So those cases where you need a faster startup, you would probably use the client compiler. C2 compiler, or also known as a server compiler, is meant for those scenarios where exactly you wanted to run your transaction faster. Okay. So C2 compiler is mainly for transaction-based application at the server side. And we have also a concept called tiered compilation, which is a mix and match of both C1 and C2. So our current JDK version, let's say JDK 11, uses both C1 and C2. So our JVM in JDK 11 is intelligent enough to use whatever is optimized for the current scenario. Okay. During startup, it will use C1 compilation. During once that JVM gets settled down and runs for quite some time, then the C2 compilation kicks in and helps you to optimize your execution of your Java program efficiently. Okay. Anyway, we'll go through all these nitty-gritty details of C1, C2 compilation, as well as the tiered compilation in our course. Okay. Jit compilation, coming back to the Jit compilation, it provides you an environment to make your Java program run faster, for sure, as I already discussed. It also does few other things, which is very, very important to understand. What it does the code optimization. It does the date code removal, inlining, very, very important topic to understand how through Jit compilation, you can make your Java program run faster, right? So those are the concepts called code optimization, date code removal, inlining, and something called caching, root cause, monomorphic dispatch is another topic, another important topic, which helps to make your Java execution faster through Jit compilation. Okay, these are these are the topics which is definitely going to be part of our discussion in the training itself, right? There is another concept called ahead of time compilation, another way of improving the performance of Java execution, and particularly it will address the startup time of your JVM, right? So as that technology progresses, Java gets just-in-time compilation. Java also gets AOT compilation. So both this compilation, what it would do, Java just-in-time compilation helps you to execute your program much faster than the traditional interpretation-based mode. AOT compilation is another way of improving the performance of Java program, and in particular, startup time of the JVM. Okay. Now, the next topic is the garbage collector. So, but before going into the garbage collector, I would like to take pause and try to answer your questions if you have any. So please feel free to unmute yourself and ask question.
We are good here, Sourav.
Okay, great. Guys, I think I am able to clarify your doubts here, but as I mentioned that not every single topic we can cover in this demo session. But surely these topics will be dealt in detail and covered in detail during our training session for sure. And it will definitely help you to improve your understanding on Jit compilation, how it is going to help you to get a faster execution of your Java program, right? All those techniques and the relevant tools will be discussed in the training session. Okay. How many more minutes we have, Kishore? We can have another 30 minutes, right?
Yeah, please go ahead.
Okay, great. So this is
session to YouTube, so please go ahead. So we can take another. You can take another 30 minutes.
Okay, great. So garbage collection is another very important topic in the Java runtime environment, right? Garbage collection, the name suggests it's a process through which Java collects garbage. What exactly meant by garbage here, right? So Java is object-based language, right? Object-oriented programming language. So It does whenever you are dealing with objects, okay? Your objects is basically, there is a two concept called class and object in object-oriented programming language. Class provides you a template. Object is basically an implementation or a physical implementation of your class, right? So you need to have a memory allocation for your object, okay? Let's take an example is class is an employee. Employee is a class which does having, let's say, name as one of the property. It may have your age, your salary, your current band. Okay, so all these details, all these properties part of your employee class. Now, when you create an employee object, let's say ABC with the name ABC, now what it will do, it will create or it will get an allocation in the memory itself, right? So object definitely, I would say, is the physical implementation of your class, and it gets stored into your memory. Okay. If you want, I can go through this in detail in the training session, what exactly and how this allocation happens in particular. But understand this object requires a memory, right? And it has to store in the heap to work on that particular object. So object definitely requires your memory. Now, through your runtime, is the object cannot always be referenced. Okay, you are creating hundreds and thousands of objects during the Java runtime. Not all objects will be referenced throughout that execution time. It is not possible, and it is not practical as well. Okay. After certain times, when that object become unreferenced or unreachable, these objects become naturally eligible for garbage collection. You don't need that object by your program at this moment. So what's the point of keeping that objects? And means if you're keeping that object, naturally it will occupy the memory. So you have to free up the memory, right? There is no point of keeping that an object which is not being referenced by any other objects in the current execution environment. So since the current object, the employee object ABC is not being referenced by any other objects, at this moment, it is naturally selected for garbage collection. Okay. Garbage collection is a process which is provided, is a basically, it provides you that interface. As a part of JVM, by the way, I already mentioned the GC is a part of JVM. It provides you an interface through which you can handle the dynamic memory allocation request, as well as it provides you an interface through which it can collect back those unreferenced objects from your heap. Okay, so let us go through this slide, right? A garbage collector performs what? Automatic dynamic memory management through the following operations. What it does, allocate form and gives back memory to the operating system. Okay, so you probably have seen that whenever you are trying to run a Java program, you are passing some argument called XMX or XMS. Okay, one is called maximum heap. Sorry. Another one is called startup heap, right? So those we'll go through those arguments definitely in the training session, but just to give you that understanding that XMX is the max heap that we are trying to allocate to your Java program. Okay, so and where from it takes, definitely it takes from that operating system, right? It takes from the main memory, available main memory, and that main memory is being handled efficiently by the operating system. So garbage collection, part of the JVM, helps you to allocate from or give back memory to the operating system. Okay. It helps you to allocate memory to the objects. Okay. So you need, whenever you are creating an object, let's say employee XYZ, then this GC is meant to allocate memory to that, JVM is meant to allocate memory to that object. Okay. It helps you to reclaim the unused memory and doing a cleanup as well. As I mentioned, if that object XYZ is not currently being referenced by any other objects in the current runtime environment, it is naturally eligible for garbage collection. So garbage collection helps you to reclaim back those unused memory or those unused memory by used by the objects which are not referenced at this moment, okay, and gives it back to the application. Okay, so it collects the amount of memory just by checking which are the objects are not being referenced, claim it, and then give it back to the pool where from it can again start allocating to the new objects. We'll have a few steps how this is being done in next few slides, but let's try to understand the garbage collector, what it does, right? Main function of garbage collector is to manage the memory efficiently for Java runtime environment. Okay. There are quite a few processes to improve the efficiency of this problem, efficiency of this operation. So we'll go through one by one. I'll skip this GC ergonomics for the time being. Rather, let's go to this slide of how the Java garbage collector implementation was done. Okay. You probably heard of generational hypothesis, right? So our JV, our heap, right? We are talking about heap. Heap is, just to give you the introduction again on the heap. Heap is a memory area which is dedicatedly being allocated to the Java program to run your Java program in nutshell, right? So it's a area, part of your main memory, which you can mention what size it should be through XMX or XMS, okay? You can run your Java program within that specific memory area, right? It is called as a heap memory. Now, in the heap memory, we have different generational areas allocated by the JVM, right? You probably heard of young generation and old generation within the heap, which is being allocated by the JVM. Have you ever thought that why a total heap is divided into two areas, young generation and old generation? What is the hypothesis behind it to divide into two regions called young generation and old generation? Okay. Sun Microsystem did a study, okay. If you are able to see that graph pasted here, it is from the Sun Microsystem and now Oracle, okay. What it shows that most of the objects die young, okay. So the generational hypothesis suggests that most of the objects die young, okay. So what it does, there is no point of keeping a single area to allocate memory for each and every object, okay. What the engineers thought that better than one memory area, let's divide the entire heap into two areas. One area would be completely dedicated for the young objects, and another area would be dedicated for the old or tenured objects. Okay. Young generation is an area where exactly we are allocating the objects which are newly created. Okay. So if you look at this particular picture, the entire heap is divided into two areas, young and old. Okay. Young generation is meant to allocate the objects which are newly created, and those objects which have survived multiple garbage collections or become tenured are meant to store in the old generation. Okay, I'm repeating, based on the generational hypothesis, which shows that most of the objects die young, that Sun's engineer came up with an idea of dividing the whole heap into two areas called young generation and old generation. Young generation is meant to allocate objects for young objects or newly created objects, and the old generation is meant to store those tenured objects which have survived multiple garbage collection cycles. Okay. If you deep dive further into this young generation, you would probably see three more areas divided into Eden space, survivor space 0 and 1. Okay, let's not talk about the virtual at this moment. It will get more complex, and we are going to cover it in the training session for sure. But just to be in a nutshell, young generation is further divided into three areas called Eden space, survivor space 0 and 1. Okay, Eden, why it is called Eden? It's an Eden garden where when God created earth, he created Eden garden, and he put a life in the Eden garden, right? So from that terminology, it came as the Eden space in Java garbage collection. So all these new objects, whatever you are going to create through your program, are firstly allocated into Eden space. Okay. Eden space is one area where exactly you are going to allocate your newly created objects within young generation. Okay, so young generation specifically meant for allocating memory for newly created objects, and to be very precise, it's the Eden space where that objects are getting allocated. Okay, now once that objects filled up in the Eden space, a minor collection will be kicked in. Okay, these are quite a few important topics that I'm just giving a understanding for the time being, and we'll go very detailed in or during our training session. So minor collection versus major collection. So minor collection is what? You are running your garbage collection in the young generation, which is nothing but a minor collection. Okay. Wherever you are running your garbage collection through the heap, throughout the heap, complete heap, it is known as a major collection. As you understand, minor collection runs against the smallest area of the heap, so definitely it runs faster. Major collection, on the contrary, runs through the entire heap, and definitely it is a more complex. It takes more time to complete. Okay, so few other important topic of garbage collection performance, something like you probably heard of latency, you probably heard of throughput, right? So let's try to understand what the latency and what the throughput means. Okay, so let's go through the throughput first, right? So let's take an example of a scenario. Let's say You are running your Java program for 100 seconds, right? And you have spent 5 seconds behind garbage collection. Okay, so your throughput is 95%. So 5% of the time you are, you would say it's not exactly wasting, because garbage collection is an important step for your effective memory of, utilization. So, but you are spending 5% of the total time behind garbage collection. So your throughput drops. You only have, your application only has 95 seconds to execute its uh, execute the program, right? So out of 100 seconds of execution time, 5 seconds being spent by the garbage collection, 95 seconds being spent by that program itself. So throughput here is 95%. Okay, this is an at a very high level what does the throughput means. Okay, latency, if your latency means how much time exactly you are spending behind garbage collection. So 5 seconds is the cumulative time, the total amount of time you have spent out of 100 seconds behind garbage collection. So 5 seconds divided by how many times the garbage collection was being called is the average latency for garbage collection. Okay, let's say within the 100 seconds of execution of your Java program, you have the JVM called 5 times garbage collection process. So latency is, total time was 5 seconds and the number of call was 5. So latency on an average, it was 1 second. Okay, a simple example of latency and throughput. Nevertheless, if you are seeing the throughput dropping and it even drops beyond 90%, means lesser than 90%, is definitely not a good sign for your Java runtime environment. And definitely that shows you that area of improvement for sure. You would be encouraged to understand why there is a drop in the throughput, and your job would be to identify the problem, bottleneck, and rectify it and improve the throughput. At the same time, when you see that the average latency goes up, that is also not a good sign, because you are spending too much time in GC, which is detrimental for your performance. Because each time you do a GC, there is an associated application pause time, or popularly known as stop the world events, which is stopping all your application thread and eventually slows down your application performance. So this is not a desirable behavior. Okay, as a performance engineer, our aim would be to maximize the throughput and minimize the average pause time for each and every garbage collection activity. Okay, throughput and latency we covered. I would like to show you a typical GC log, how it looks like. Okay, so a typical GC log contains, you don't have to understand each and every portion of it. Here you are able to see pause young. That means this garbage collection happened in young generation. Okay, this memory versus this memory, what it does, and this memory, there are three sizes mentioned here, right? 307 is the total heap size at this moment. 239 MB or megabyte is that before the garbage collection kicks in, what was the memory size and how much memory it can claim back through garbage collection. So it is 239 minus 57. This is the memory it was able to claim through this garbage collection cycle. Okay. Last but not the least, there is a value here, 5 5.048 ms, means it's a 5048 millisecond. What does it mean and how it is very significant here? It says that that particular garbage collection process took 5.048 seconds. 5048 millisecond means 5.048 seconds. So it gives you very valuable information. What are those information? This garbage collection happened in young generation. Okay, it was able to claim back 239 MB minus 57 MB of memory, and in the process it took 5 seconds. Okay, if you go to the next line, it shows you 16 seconds of garbage collection time, right? Definitely 16 second, 5 second, this is just an example. In today's world, anything more than 100 millisecond is definitely not a good sign. Okay, we have bigger and better garbage collection available. I will take you through at a very high level now, which are meant to provide you low pause time or low garbage collection time. Okay, by introducing concurrency, by introducing parallelism, you would be able to achieve much faster garbage collection and much more efficient garbage collection in today's world. Okay, 5 seconds, 16 seconds, definitely it's not a desirable behavior anymore. Right? This is just for your example to understand how the garbage collection log look like. And nevertheless, you probably heard of garbage collection G1GC or CMS garbage collection. The log for those garbage collection is very complex. If you are going through for the very first time, it would be very tough to understand what exactly it meant. Okay, so I picked up this simple example just to go through these numbers and make you understand how it looks like. Okay. Okay, so I was talking about steps in garbage collection. Okay, I would like to take a pause. By the way, I was speaking in a tandem. I would like to take a pause and ask for any question if you have. Do you have any question? Okay. I hope you are able to get all the points that I've been explaining.
Sourav, I have one question.
Yeah, sure.
This is Shweta. So,
Hey, Shada.
what is ideal? Like when do we say that the garbage collection is taking much time, and this is the optimal time to actually, um, uh, uh, required to tune on major and minor collections.
Yeah, definitely. Means as I mentioned, few indicators I've already given. Like if you have a throughput less than 90%, right? So out of 100 seconds, let's say you are spending 10 seconds in garbage collection, which is not a good sign for sure, right? Because only 90 seconds you are giving to your application thread to run. So that's a one indication that your Java or runtime environment is not running optimally. Another indication could be your average pause time or latency for each and every garbage collection cycle. So if you are spending, let's say, in today's world with garbage collection G1GC, if you are spending more than 1 second for each and every garbage collection cycle, that is not also good. As a standard, according to my experience, anything greater than 100 millisecond in nowadays for G1GC is not a good sign, right? And it will eventually become a point to investigate further. Okay, so what I'm trying to tell you is these are the indicators, and you would be able to understand that something is not right. Now, why it is being caused, that is another set of investigation that we have to perform, right? Why garbage collection takes more than a second? Why throughput is low as less than 90%? These are the indicators, right? These are symptoms. These are not the root cause. Now you have to go down one step further to understand and take a deeper look at how the Java runtime system works and why it is causing slowness in the system. Did I answer your question, Shweta?
Yeah, sir. Yeah.
Okay, great. So now let's quickly go through the steps in nutshell. So steps, garbage collection steps contains three. It's a three-step process, right? It has to mark, it has to delete, and it has to compact. Okay. What do you mean by mark? JVM follows an unique way of identifying reachable objects, right? Reachable objects, you probably, if you are having understanding on the tree architecture, tree data structure, okay, you probably understand there is a root node, okay, and each and every object allocated in the heap, Java maintains a tree data structure for this, okay. So if an object is reachable from root to the node leaf node, okay, that means that object is reachable, okay. You have 10 objects at this moment, example, in your heap, okay. Now out of 10 objects, you have only 8 objects which are reachable from your root node to your leaf node. Now the remaining 2 objects, in any way you are not able to reach out to them, okay. So marking is a process to identify reachable object. There is a misconception that garbage collection will help you to detect unreachable objects. It's not a correct statement. Garbage collection is a process through which you can identify the reachable objects, okay, and you can mark it as a reachable. Now, anything which is not marked falls under unmarked category, right? And if that object is not marked, it will be eligible for garbage collection. So I just wanted to clarify that thing, that there is a conception called identifying the unreferenced object or unreachable object, right? In no way Java or JVM can detect those initially, right? It can detect only the reachable objects and mark them. And anything which are not marked by default became ready for garbage collection. Okay, so marking phase is to identify the reachable object. Next step is those objects which are not marked are ready for garbage collection, so it will be collected through this deletion process. And the last but not the least is, once you delete those objects which are not reachable, it creates a hole in the heap, right? So compaction is a process through which you are just reorganizing your live objects to a contiguous memory location, okay? On Windows in earlier days, we used to do a fragmentation, a defragmentation quite often, right?
Yeah,
This defragmentation. Sorry, hello?
Yeah, this defragmentation, that's what I
Yeah.
meant.
So this defragmentation we used to do. Why you used to do it? Because we used to ensure that that content of the disk are written in a contiguous location so that the disk will be used very effectively. Why it is so? Earlier days we used to use rotational disk, right? Now, during this performance engineering training, we'll be covering why rotational disks was slower, why SSDs are faster, right? That's a separate topic, but I just wanted to give you the glimpse that rotational disk is not very much slower than that very, very slower than the SSD one. Okay. Now on SSD, we have two different protocols. One is SATA and another one is NVMe. So traditionally, you are probably for your laptop, most of the laptop nowadays comes with the SSD SATA, right? But there is another protocol which is much, much faster, right?
What is the other?
NVMe.
NVAV.
Yeah.
Okay.
So SATA is basically somewhat we made it working with SSD, but SATA is not a ideal or optimal protocol for SSDs. NVMe is the ideal or optimal protocol for SSDs. So which is much, much faster than even for SSD with SATA. Okay. Why we are calling about this defragmentation? Earlier days we used to have a rotational storage, right? Rotational disk, right? And we used to have a head, right, read or write head, which used to move between different sectors to read that or to write into a sector, right? If it is not being defragmented, it would have a higher seek time, right? And it would slow down your access time. That is why we used to do a defragmentation after a few days, right? Probably once in a month at least. I remember my college days. Similarly, in Java garbage collection, right? This young generation and old generation are in contiguous location, but during this deletion process of undisable object, that will create a hole in the heap, and eventually that may not be big enough to allocate further objects. So as a part of garbage collection, the last step is the compaction, which is basically reorganizing the entire heap with the live objects or reachable objects. Okay. So marking, deletion, compaction, three-step process for garbage collection. I'll quickly go through this available garbage collector in JDK 11. One is called serial collector. Second one is a parallel collector. Third one is a concurrent collector, and the fourth one is a very, very new collector called garbage. G is garbage collector. Okay, we all colloquially we call it as a GGC. We'll not talk about GGC right now, but rather focus on serial, parallel, and concurrent collector. So you probably heard of serial GC. Okay, serial GC is a single-threaded GC, as the name suggests, and it is definitely slower, right? Serial GC is still available, and it is available just to support your single-threaded GC requirement. If you are using a laptop where you don't need multiple threads to run your GC, you can still use serial collector, and that would be efficient for your use case. Parallel collector, as the name suggests, it provides you parallelism when you are doing the GC activity. Okay. So during the garbage collection, when the garbage is collected, it can be collected through parallel GC threads, right? That's what the parallel collector comes into the picture. There are two options. One is called use parallel GC, and another one is called use parallel old GC. There is a fundamental difference between these two garbage collector algorithm. Parallel GC is meant to provide you a parallel thread in young generation, but not in old generation. Listen carefully. Use parallel GC. This algorithm provides you parallel threads for your young GC collection, not for your old GC collection. Old GC collection will still be single threaded. But if you choose use parallel old GC algorithm, okay, so one is use parallel GC, the second option is use parallel old GC. This will give you parallel threads for your GC, both in young generation and old generation. Okay, So right now we have two collectors, serial collector and parallel collector. Within parallel collector, we have two different algorithms called use parallel GC and use parallel old GC. The next collector is a concurrent collector. Okay, concurrent collector means all the GC activity can be run while your application already running, right? So with serial collector and parallel collector, the problem comes when the GC runs, application thread needs to be paused. Okay, there is a stop of the world event, which is stopping all the application thread from running, which is definitely detrimental to your application performance. During the GC time, every single application threads were stopped. Okay, that means you would probably see no response from your application itself. This is definitely not a good way of handling your application. So engineers at Oracle came up with that idea of concurrent garbage collectors. Concurrent garbage collector would not stop your application thread, and rather, let me rephrase, would try to stop your application thread for a very minimum period. Okay, and most of the garbage collection activity would go in hand with your application threads. Okay, with earlier approach like serial and parallel collector, entire GC process will stop your application thread. But in the concurrent collector, we would have a process or approach, optimal approach, so that we would have a very minimal pauses from for application threads, right? Algorithm like CMS, G1, GC are the concurrent collectors, example of concurrent collectors, right? We'll go in detail about how CMS and G1, GC helps us to improve that pause time, application pause time in detail, okay? What are the techniques and mechanisms they are using to improve that minimum pause time through concurrent collectors. Last but not the least is ZGC or G garbage collector. In recent JDKs, we have a few other collector being introduced like Sinando, okay, which is again a low pause collector, right? As the time progress, as the technology evolves, our one of the main goal is to improve that pause time, right? That is to lower the pause time. We should not stop our application thread for a very long time. And that is how, Shweta, I answered your question, right? If you're seeing that application pauses are more than 100 milliseconds, that means during that time, no application thread are in action, and that would eventually add it in your application response time, right? The longer it is, you would have a worse response time for your application, right?
Yes.
So as a performance engineer, your aim is to improve or to lower that application pause time created by garbage collection. Okay. So there are few use cases at a very high level. We can go through it if you are interested, but each and every use case with a proper example we'll be covering in the training session itself. By the way, each and every training session we would have an equal amount of hands-on exercise that will be given by me, and you have to set up probably in your system, or we will probably give you some offerings, right? Kishore, if I am wrong, please correct me. Some sort of lab environment, will that be given on cloud?
Yeah, sir.
Okay. But I would try to make sure that you can equally run these examples, or you can equally run those program on your laptop or desktop as well, right? At anytime whenever you need, right? So different approaches, different garbage collection behavior would help you to identify the best algorithm to choose from based on the need that your application demands. Okay, and all this permutation combination of different scenario, how you want to debug an issue, right? I just talked about the issue today. What issue? If I say that garbage collection take 1 second, but how to debug it? All these things should be covering in that section. Okay. With this, I would stop for today, right? And the floor is open for any question and answer for another next 5 minutes. So please feel free to ask. Any questions on this? Guys, are you able to get all the points that I discussed? At least if you can acknowledge, that would be really great.
Yeah, thanks, Sourav. Thanks for the detailed session. So I have one question, like, in the heap architecture, right? So we explained, like, why that hidden space was named so. So I have one question here. So why are there two survivor spaces? Why
Okay.
not one, and why do we have two survivors?
Okay, so two survivor spaces. Okay, I have to go through this in detail, right? So once that object is created, it will be first allocated into hidden space. That's what we understood, I believe. Okay. Now, once the hidden space is filled up, right, it will be copied to survivor space 0, right? Now, at a time, you would see that one of the survivor space is empty.
Yeah, can you please go to that slide here where you have that heap architecture diagram?
Right?
Yeah. Thank you.
Okay, so my point is that once the hidden space is full, right, it would invoke a minor GC. Okay.
Right.
Now the minor GC, what it will do, it will detect those reachable objects and copy them into survivor space 0. At this moment, sorry.
Right. Yeah. Please go ahead.
At this moment, after the first phase of garbage collection, your survivor space 0 is partially filled and survivor space 1 is completely empty.
True. Yeah.
True. Okay. Now again, a new set of objects are being allocated in the hidden space, right?
Right.
Again, it will fill up. It will again trigger for another minor GC, and the reachable objects will be again trying to fill it in the survivor space 0 until unless it completely gets filled up. Okay.
Okay.
Now move forward. We have a scenario that survivor space 0 is completely filled. Okay. What would happen? Through minor collection, it will detect what are those objects which have survived at this moment and which are reachable. Those are all will be copied into survivor space 1. Okay.
Okay.
And now survivor space 0 is empty. Okay.
Right.
Now the cycle continues till the survivor space 1 is completely filled up, and it can again all the reachable objects copied back to survivor space 0. Okay. And the cycle continues. Why two survivor space? That's what your question is, right, Kishore?
Yeah.
Number one, this survivor space is an automatic choice for your compaction. Now understand that once hidden space is completely full, right? You invoke a minor collection. Okay. Now the reachable object, only the reachable objects will be copied into survivor. Now once it copies into survivor space, that is in contiguous location. Are you getting the point?
Yes.
automatically that compaction is running without doing any extra step. Okay, so efficiently we are able to use the memory. Okay, number two is that there is a concept called max tenuring threshold values. Okay, max tenuring threshold suggests that how many times an object has to live within young generation before it gets promoted to old generation. That means how many times within young generation an object has to survive garbage collection before it gets promoted to old generation. So I'm saying that an object which is reachable has survived 15 times. So by default, max tenuring threshold value is 15. That means an object has to survive 15 times garbage collection within young generation before it is eligible for promoting into old generation and becomes a tenured object. Okay. Why we are having this, right? To age out the object within young generation by providing two survivor spaces, right? So that it can be copied back and forth and it can survive multiple cycle of garbage collection.
Okay.
So two fundamental reason of having two survivor spaces. It can be more, but let's stick to two. That is the design, right? One is it provides you a by default compaction feature, right? It can help you to efficiently use your memory efficiently. And the second one is that it will help you to age out the objects before it gets promoted into old generation. We wanted to do more minor collection. Set another pointer to you. If you are seeing that more and more major collection are kicked in, that is also not a good sign, right? Because major collection brings a lot of overhead into your application. So from a performance engineer point of view, we wanted to make sure that we wanted to keep the major collection as minimum as possible. Rather, we can have a considerable number of minor collection. That is desirable behavior. Okay. Again, the point here is that minor collection are having less overhead on the system and application than the major collection. Hence, it is a better choice for sure. Did I answer your question, Kishore?
Yeah. Thanks for that. Yeah.
Okay. Any more question, by the way? That's a good question, actually. Why two survivor space? You may face this question from an interviewer for sure. Okay.
Yeah, true. That's true.
So, any more question, guys? Okay, I think we're able to explain it probably in a better way so that people are able to understand it. So, Kishore, I think that's it from my side. I am done with today's session. Okay. Another thing we can do, Kishore, sometimes next Saturday in the evening, right? We can plan for another demo session.
Sure, yeah, definitely.
Okay. Probably we can pick up something very interesting for all of us, maybe from the UI performance or from database performance. I'll decide and let you know, but you can definitely schedule one more session on Saturday next week in the evening. Okay. So over to you, Kishore. I'm stopping my presentation. Yeah, Kishore, please feel free to take it over.
Yeah, thanks, Sourav, for the detailed session. So, let us close the session for today. So,
Yeah.
as discussed, like we will plan the next session on Saturday, next demo session. That would be the final demo session on Saturday.
Yeah.
Thanks everyone for making to the session. Like I know like it's a bit difficult on Sunday morning. So thanks everyone for making the session. Thanks for your time.
Yeah. Thank you guys. Have a good day. Bye
Thank you
bye.
all. Bye.
So please, reach out to us. Like I would like to show my contact number and mail ID. So please reach out to us in case of any further information.
Sure. Thank you.